Okay, so we're going to be looking at creating a standard solution, which is one that we know the concentration really well. We're going to do this by dissolving a primary standard. A primary standard is a solid that can be obtained in a really pure form. If you leave it out in the open here, it's not going to absorb moisture from the air, it's not going to react with anything in the atmosphere as well, so that if I measure out a certain mass, I'm confident it is exactly this chemical. On the left-hand side here, I have a primary standard oxalic acid dihydrate. This one here is an acidic standard. It happens to make an acidic solution, so pH less than 7. Baking soda, sodium bicarbonate here, which is referred to as a basic standard. It can also be sort of left out. It can retain its purity here, so we have baking soda there. Let's just compare this visually here to sodium hydroxide in the middle here. Sodium hydroxide here would not be a good starting material. Sodium hydroxide, although it can also be obtained as solid, although you could also weigh out a mass, you'll notice in leaving sodium hydroxide out, it used to come as little white pellets here. You'll notice that it's absorbed a lot of the moisture in the air, and therefore the purity has dropped quite a lot. If you do calculations and you make solutions with this sodium hydroxide, I'm actually not confident how much of that mass that I actually dissolve is actually the sodium hydroxide pellets versus the water that's actually absorbed. So we always want to start off with something that's chemically pure. I'm just going to demonstrate for you how we create the standard solution here. I have my mass balance, it's already zeroed here. Let's say I want to make 100 mils of my standard solution. You're going to take your container, whatever you're going to be dissolving in. If you need to, you can measure the mass of the empty container here. I usually just zero it so that I can sort of forget that mass there. You would, in whatever lab that you're doing, you would have a certain mass that you're trying to dissolve out. So I'm just going to pour a little bit of this into my beaker here. Let's say my experiment called for 0.3, so I'm going to try to add a little bit more as I scoop in that. All right, oh, I went over, that's okay, right? You're just going to use this number here. You have an error of plus or minus 0.01 here, okay? But as long as you use this number for your calculation, I'm going to still know the concentration really well. Chemically, it would have retained its purity. Because I know I'm going to be eventually making 100 milliliters of the solution here, I'm just going to dissolve this in something that's less than 100 for now. So I'm just going to add some water here. Okay. Swirl it around a little bit here. Might be easier if you use a glass stir rod as well. Crush up some of that powder. Remember, the beakers will only be able to give you very approximate volumes. I'm going to be transferring this into a volumetric flask, which is a lot more precise. So just dissolving the oxalic acid. Okay. I have my 100 milliliter volumetric flask here. I'm just going to pour it in. Okay. You just want to make sure the water that you use to dissolve it in, any rinses that we do, maybe there's some leftover, you see a little bit of oxalic acid left over there. Any additions of water that we do, we want to make sure it's just far away from the 100 mark so that we don't accidentally overshoot the mark eventually when it's in the volumetric. So just going to try to dissolve that a little bit better here. Again, just transfer all your rinsings here into the volumetric. When you're confident all the oxalic acid is out of your container, we can add water directly to your volumetric flask here. So near the bottom here, it takes a little bit to actually start coming upwards. As I get really close to the top here, best technique would be at eye level. You can actually use a dropper for this narrow neck portion here. So I'm just going to grab a dropper here. I'm going to be at eye level with it here, and I'm going to just add water until it actually hits the mark. I want to make sure the bottom of the meniscus is exactly at that mark there. That there is exactly 100.00. It's really well calibrated for. If you need to do some additional mixing, you can just seal the top here, very gently rock this one here back and forth. That's just going to ensure the whole thing gets mixed. And there we go, we have created a standard solution where I know the concentration really well. I had the mass recorded. Because this was a primary standard, I'm confident that it was 100% pure. If you do want to be doing a titration with the solution here, remember you want to transfer this solution here into another container before you do any pipetting, just in case you damage the volumetric. Thanks guys.